Hi everyone, I think we would start with a talk now from Oliver. If you don't mind coming to the front row as possible. Gail, Fabian, and Theo. Sorry to interrupt. But there's lunch afterwards, so. Should remember that tomorrow. Okay.
Today I will talk about self-sovereign identity and how this could become a tool for GDPR compliance. I'm Oliver. I work with Consensus on the uPort project. I'm an identity architect, and please feel free to contact me if you have any questions after the presentation. I'm also a member of some standardization organizations which work on the standardization of self-sovereign identity. The Consensus is a global venture studio. I think many of you or most of you are familiar with that. And so we also work on different projects like Kaleido, DataMask, Truffle, and also uPort, which is the self-sovereign identity solution of Consensus. And we also work on the core infrastructure of Ethereum, like MetaMask, and also with Antium, an enterprise Ethereum client, and Fura, Truffle, etc. And yeah. So, what is identity today? Or what is identity actually? Usually, identity could be divided into two categories. So the first one is to access traditional services. We usually have a paper-based or smart card, and this is then needed to interact with a government, with your bank, university, health insurance, and so on. On the other hand, you have use identity to participate in a digital world. Use it for, you have different kinds of usernames and passwords for all these service providers. Use it to sign up with your email provider or interact with your social or professional network. So you can see that identity is not a single static identifier, it's more like a set of attributes which captures all interactions, behaviors, and transactions. There are different identity approaches, and one of the first one was the siloed approach. Typically see this with healthcare, bank, and governmental institutions. There the identity is locked down in silos. The user has different accounts with every of these organizations. It's not easy to exchange data between these heterogeneous organizational boundaries, so it causes a lot of friction. It's also quite expensive because you have to have redundant storage and so on. The next approach is to have a third-party identity provider, and you all are familiar with that. And in this case, the identity is scattered across the internet, and it's also not very privacy preserving. I mean, it's somehow convenient because you log in once using single sign-on functionality, and then use your Google account with Spotify or some other web service provider. But it really essentially means that these providers, they can easily track and trace the user, they breach profiles, can mine the user. So you are their business model actually. And we also really heavily rely on the availability and the governance and the business model of these organizations. And our data is a constant risk. We rely on the security and privacy controls they implemented. And this is a list of data breaches that happened last year, 2018, and we see that there are a lot of companies, big tech companies in there, like Google, Facebook, and Marriott has a record of 500 million data breaches and data records last year. It's actually terrible. So this is why we introduced, or it's a different approach to identity actually. It's called self-sovereign identity, where the user is put at the center again, which provides a more holistic view. And identity is not static, it's completely integrated into our daily lives. It becomes a rich set of all interactions with the people and organizations around us. It makes actually possible to interact with each other in a way that was previously unimaginable. And this is why we call it self-sovereign identity. And in this paradigm, it's especially important to implement security and privacy controls very carefully, because the user has the ultimate control about her or his data. So the idea is that the user collects these attestations and authorizes data about herself using an identity wallet, for instance. And only the user has the sole control about the private key to his identity wallet. And in order to become this self-sovereign identity future reality, we know that we need strong interoperable standards in order to get global acceptance, mass adoption. Because we in uPort, we work on an SSI solution, but we won't be the only SSI provider, not the only SSI wallet. There will be many others, and it's good because competition increases the chance of mass adoption. And it's already happening because we come together in WSLC and in the Decentralized Identity Foundation to work together as a community on these standards to become this a reality. And most importantly, we have now two specifications which are more or less mature. So the first one is the Decentralized Identifier specification, which originated from Rebooting Web of Trust and was developed in the W3C Credentials Community Group. So all these SSI people almost agreed on this, and we will also soon define the specifications. And based on that, on top of that, we have the Verifiable Credential specification, which uses these decentralized identifiers. And these are the two important standards which are the base, which are the foundation of SSI. So how do these standards or concepts really work? So I talked about the decentralized identifiers, DIDs, and it's basically a new type of identifier, unique identifier. And a DID, simple as it is, resolves to a DID document, and the DID document on the right-hand side contains cryptographic information of the ID owner. You could use this information to allow verification that the user proves possession about a certain data. And you could also use these keys to encrypt messages to the owner or to the verifier, have mutually authenticated channels. So it's really great. And these DID documents would also contain public information, public claims about organizations, and service endpoints to communicate with services that act on the user's behalf. And these DIDs and DID documents, they can be anchored on blockchain, they could be stored on blockchain, or on any distributed storage media like IPFS. And another property is that they are universal discoverable. We are sometimes talking about, this is a decentralized PKI. This is actually enabled by blockchain. It's very similar to X509 certificates, which are used with the traditional internet PKI in the Web 2.0 area. But it doesn't require any certificate authorities anymore. You don't need any intermediary, because the blockchain is the source of truth. These DIDs, they could be anchored on any type of ledger, DLT, or distributed storage. And in uPort, we use so these DID methods actually define how to do the CRUD operations, create, read, update, delete, on a specific storage medium. And also how to change the key of the identity owner or add service endpoints and stuff. And we have a broad variety of DID methods. So in uPort's case, we use the DID Ether method, YOLOCOM, or we heard about YOLOCOM is also in this company. They use the YOLO, and there is also the sovereign DID method. In they all provides an abstraction layer in order to obtain these DAD documents. This is how a uPort DAD looks like. It's essentially only a public Ethereum. It's actually derived from the Ethereum key pair. It's a Ethereum address, which also has the advantage that every Ethereum account becomes automatically decentralized identity. And we tried a couple of approaches over the last few years and also implemented a proxy-based approach. But for practical reasons, we decided to implement this method because we don't need any Ethereum transaction upfront in order to create a DAD. Only if you change the keys or do some modifications to the DAD document, you would need an Ethereum transaction. So this is really something that facilitates the offline, off-chain credentials exchange. And so how do these verifiable credentials work, actually? So as mentioned earlier, WSRC is about to finalize the specification. First candidate recommendation will soon go to the WSRC committee and then receive a final draft very soon. A verifiable credential is really just claims about the user. It can contain any data. And how do they work? Always have an issuer that creates these credentials. And this credential, you have the DAD of the issuer and of the user. So it's all cryptographically protected and verifiable. That's why they call it verifiable credentials. And so in case your university issues you a university certificate, they create a credential, sign it with the university's DAD, send it to the user's identity wallet, the user stores it there, and the user will then be able to present this credential to any type of organization, person, whatever. And the consumer will then be able to verify that the user is in possession of the credential and it was signed by the issuer. In that case, in the university case, it could be, for instance, LinkedIn or so on. And this really facilitates we had in our the identity models that I talked earlier. It was very complicated to exchange information between organizations, and this really facilitates the credentials exchange between heterogeneous organizations. There is no limitation actually. Even if the DADs are anchored on different DADs, it should be interoperable. Yeah. And because of the DAD and the specification, all these steps that I demonstrated earlier are verifiable. So, great, but what about GDPR? Because I told you that, especially in this identity model where the user has full control, more control, it's especially important to implement security and data protection strategies carefully. What is GDPR? I think that you all know, but just to recap, actually GDPR has two different purposes which are equally important. The first one is to give natural persons more control over their own personal data. The second one is to enable free movement of personal data across the European Union, which is also very related to data portability. The European Commission, because GDPR was developed when blockchain was in its infancy, and so it wasn't really designed for that. And the European Commission set into force the Blockchain Observatory Forum. It's actually it's a forum of experts of different types across different verticals, different areas. And there's one expert group, one working group that is working on GDPR-related topics, and they published a report last October, which is publicly available. You can look it up on the internet. And essentially, it means that according to GDPR, so it's not about the technology itself. There is no such thing as a GDPR compliant blockchain. As The same as there is no GDPR compliant internet or artificial intelligence. It really depends on the use case and the application. You have to identify the problems case by case in order to find the appropriate strategy. Went wrong. But in the report, they also identified a lot of tension between the GDPR and blockchain. The report is also, you also have to keep in mind that this was an expert group, but it was no final decision approved by the European Commission. So there's still a lot of unclarity and things that need to be explored. So one of the tensions is basically who are the data controllers? There is so who is actually in charge and responsible of that the data processing is GDPR compliant. Especially with public blockchains very challenging. It should be desirable that actually developers shouldn't be responsible to become the data controller, because developers, they don't have any incentive. They just want to develop the core protocol. And I think that this is more like, this is pretty sure that they are not gonna be liable for that. As mentioned, there is no final decision yet. Then, what about nodes? Technically, nodes don't have a means to see what data actually is executed on the blockchain. So from this perspective, it's also desirable to not have them as become the data controller, right? But still, a lot of discussion there. Users. So you have to distinguish between business users and personal or individuals. Business users who act on a company's behalf, so they run a business and execute some transactions. So they are very likely to become data controllers. But if you are an individual and use the blockchain for personal use, provide your personal information, then this is actually not, this won't be considered under the GDPR. There's also some uncertainty around smart contracts. So who is liable, the publisher of the smart contract or the user of the smart contract? Still no decision yet. Then again, next point was personal data. Its problem with personal data is that actually the GDPR really put the bar for personal data to be considered anonymized according to GDPR is quite high. So it's technically every pseudonym is considered to be a personal data and needs to be protected. And the difference, how to distinguish between between pseudonyms and anonymous data boils down to the two risks. The first one is the reversal risk, and the second one is the linkability risk. So the reversal risk is about how likely is it that you could reverse an encryption algorithm, for instance, by brute forcing it. It could also mean that as long as there exists a private key to decipher personal data record, there is also still a risk that this becomes visible or revealed in the future. Also, crypto algorithms, they are not all future-proven. They have quantum cryptography, etc. So there is technically every personal data that is encrypted using asymmetric or symmetric cryptography is considered to be personal data. It's a pseudonym. Yeah, that's the problem with that. And the other hand is the linkability risk. So as long as there is a chance to do data analytics and also use maybe external information to link to an individual, then there is also a good chance that this is considered to be personal data. Good. Anonymization. So there's a huge debate in the European Commission and the working group on how to transform pseudonyms to anonymous data, because anonymous data is not subject to the GDPR. And there are certain techniques, and there's always one big thing actually, public keys and addresses. They are pseudonyms, and so technically it shouldn't be stored on a blockchain. But you could use obfuscation techniques to mitigate this risk, or use strong encryption, hashes. There's also a big debate about hashes. Are hashes personal data? Are these pseudonyms? There's no answer yet. It depends. It's a case-by-case decision, actually. Yeah, there also exist advanced cryptography techniques like zero-knowledge proofs, like homomorphic encryption, like multi-part compute. All great and could help there. Yeah, there are also some friction and tensions with the rights and obligations which are related to GDPR, like lawfulness, data minimization, erasure, rectification, and so on. Because I told you earlier that especially hashing is a case-by-case decision, and it really depends. And these are a few examples that should demonstrate how to distinct if it's considered to be personal data or not. So if you, for instance, hash a single attribute where you know the semantic meaning, then the reversal risk is quite high if the attribute has a dedicated length, or if the range of the size is known. For instance, the social security number or a password could be potentially brute force with so that the risk there is medium. On the other hand, if you you could mitigate this risk by just adding some pepper or salt. So this is, but it depends, of course, on the size of the pepper and the salt. And usually a good strategy would be to increase the size to be safe for the next 50 years. The situation is different if you have one-time values, which would be used to notarize the state of a data set. So, for instance, you have a bunch of transactions and you aggregate them, hash them, and then send to the blockchain. This is something so actually where you don't know the size in advance. It could be some bytes, it could be also hundreds of terabytes, and in that case, the likelihood is really low that you could attack this hash using brute force, for instance. Linkability risk. So also in situation one, if you hash one single attribute, then you could easily run pattern analysis and trace data back to the individual. And so the risk there is high. And on the other hand, situation two, where you have this aggregated data set, then actually the risk is quite low because each hash is unique. And therefore there is no obvious way to cross-analyze the data. This is why I told you, okay, it's a case-by-case decision. And I mentioned earlier that the European Blockchain Observatory Forum, there was no final decision on certain friction points. But in general, they came up with a rule of thumb. What you have to take in, what you have to consider when implementing applications based on blockchain. So first of all, start with the big picture. How user value is created, how is data used, what is blockchain really used for? Avoid storing personal data on a blockchain. I think that's pretty obvious. And make full use of data obfuscation, encryption, aggregation, everything that I mentioned earlier to anonymize the data, rather than, of course, storing personal data itself. And if possible, also collect personal data off-chain. And if you can't avoid to collect data on-chain, then you should probably go for a permissioned or private blockchain, according to many blockchain experts. It's not my personal opinion, but that's actually what came out of the report. And yeah, you have to then consider really carefully. So if you connect these private permission blockchain networks with the public blockchain because it makes sense, because the actual cool thing about public blockchains is that it's visible to everyone, it's transparent, and it has an enormous economical potential. Then you have to be really careful to connect them with private chains if there's any personal data stored on them. Nevertheless, people should still continue to innovate and be as clear as possible to their users, because blockchain is still evolving. So we might have some pruning techniques, for instance, that I originally invented to reduce the size of the blockchain, but could be potentially used to erase data. And you might also see some quantum-resistant crypto. Yeah, go ahead.
Question, like, in the second point, like, how do they keep track of the private keys to decrypt, right? I mean,
Sorry,
I just wonder, in the second point, like,
yeah.
Keys for decryption must be stored someplace as well, right?
Yeah, the keys for decryption, so you usually have a public-private key,
Yeah.
and the public key is public, and the private key should be saved, only visible to the user.
So if the permission blockchain gets hacked, then we have the same problems. I don't see the difference between 2 and 3, maybe. That's just I'm wondering.
The difference is actually also about who is the data controller. With permission blockchains, it's also more easy to identify the data controller. So who are liable?
Okay.
That's with public blockchains.
Okay, so it's just the legal perspective.
Yeah.
Well, I have the culprit, and then I get the lawyer. Sorry.
I'm not a lawyer. I'm an engineer. So
Okay. Actually,
it's a good question. So is someone of you a lawyer?
No.
Yeah, sure. What's the question?
No, I was just interested in the...
We have 4 lawyers here, to be transparent. Young rights protecting.
Okay.
I was actually wondering if you are a lawyer because you talk like one.
Brilliant. Yeah.
As a compliment.
Awesome.
Because of the previous job.
Oh, yeah. Super serious. Okay. So this is actually the recommendation that came out of the report. And yeah, so if you, for instance, also one technique is, so if you have personal data on the blockchain, like public keys or something, or addresses, there's also, I think the current understanding is if you get rid of the reference data, which is kept off-chain, then it becomes anonymous data again. That's trick that people use. So I was talking about self-sovereign IDs, and so I talked about the dark sides of GDPR and blockchain and detention points, etc. But I also want to talk about how can actually blockchain technology like SSI help companies to become GDPR compliant. And in the SSI world, just for reference, the verifier, so the party where I share my data with, becomes the data controller. That's the common understanding right now. So GDPR defines a set of core data protection principles, and I will go through them. I think I did something, and I will try to map them on SSI features. So in this first case, personal data must be processed lawfully, fairly, and in a transparent manner in relation to the data subject. So it's about lawfulness, fairness, transparency. And in the SSI world, the user is always asked directly to authorize data. Always asked to give consent to selective disclosure requests. So you can even have consent receipts stored on the ledger, which could then be used for audits or proof to external auditors that data was shared and again deleted, etc. And the consent can be always revoked, and this really enables a new level of transparency compared to the Google third-party identity provider model. So the next one is about purpose limitation. And in every selective disclosure request and when you share data again, you could easily include a purpose. And the purpose will then be displayed to the user. And so the user will be able to vet the scope of the request. The next one is about data minimization. And this means that the user decides which attributes to share. The user doesn't have to share the whole passport data or driver's license if the user only wants to prove he's over 21 by alcohol, for instance, or your pizza delivery service doesn't have to ask you for your nationality while only the address and the name is needed. And with this new concept with SSI, it's actually possible to really reduce the amount of personal data that is kept in a company, because the company can always ask on demand when data is being used to get the data from the user. So you have the ability to reduce the amount of data that is stored at rest. Next principle is about data accuracy, also about rectification, erasure, stuff. And so the user has the right that the data will be updated. In the SSI model, where you have the issuer, the user, and the consumer, the issuer could always push a new credential to the data subject once the data was updated. The credential could also contain validity information, and the blockchain could then be used to track the location status. And if you use these consent receipts, for instance, then also the user could, and if the user keeps track of who he shared the data with, you could also notify or process data processors or just erase the data. It's also a common approach in the SSI world. Yeah, and data exchanges could be audited, and therefore and also the data accuracy could be retained. Good. Next principle is about storage limitation, and so there is actually no need to store personal data, except if the company needs the data at the time of processing. Of course, you will always have some situations where you have to store the data. GDPR defines some edge cases, exceptions for historical, for scientifical, and these kind of use cases. Because the verifier could always ask to get the same credential again by establishing a mutually authenticated channel, of course. And related to this is also the very popular, prominent right to be forgotten. How do we implement this on our blockchain? It's always the question. So the SSI model, actually all these data transactions, the credentials exchange, happens completely off ledger. So there's no blockchain interaction required. Always happens peer-to-peer between me and the company. I get my credentials directly from my issuer and collected in my identity wallet. So there should not be stored any personal data on the ledger. And as mentioned earlier, so even if you store the DIDs on the ledger, then technically you could just delete all the credentials which are associated with the DID, then it won't become then it would become anonymous data again. And you could also implement consent receipts. And these consent receipts would also ultimately facilitate the mitigate of unlawful behavior, because if I tell my company, please delete my data that I sent to you, and they acknowledge it on the ledger, then they didn't delete it, then it was definitely unlawful behavior and I could sue them. Next one is about integrity and confidentiality. And all these standards that are introduced earlier, these emerging standards, they allow really end-to-end encryption, which means mutually authenticated channels. So it's really facilitating security and privacy. And all these SSI solutions, they are implementing these standards. Also, uPort is implementing these standards. And this also has a side effect that because companies don't have to store this data anymore, there will be less honeypots out there. So less big data centers having a lot of user data, and so the risk decreases that these big data breaches happen anymore. Because in order to attack a user, you have to attack the identity wallet, which is typically on a smartphone, and less affected users, lower damage potential, and lower exploitability. Yeah.
But if I recall correctly, you said something like there will be an audit to be had, like all the which requests have been done and which requests have been answered. This is all stored in the blockchain.
You could do that. I saw solutions that implement these consent receipts in a very privacy-preserving manner. So they essentially use different kind of hashes, which are once you delete the reference data, become completely anonymous. Other people follow a cryptographic accumulators approach, where they just aggregate a list of revocation entries, but don't have any. It's not visible that one particular entry got revoked, for instance.
So in other words, for the average person, it will not be clear like who did what to whom, so to speak.
For the average person, definitely not. By inspecting the blockchain, definitely not. But in order to, that's a cool thing about computers, right? Because they make life easier. So people like uPort and Sovereign, they come out with SSI wallets or entity wallets, and then this helps you as a user to keep track with whom you share your data. And technically, it won't be possible to link back to the individual or break the encryption, because it's a one-way encryption, it's hashes. And last but not least, the data controller is actually responsible for and be able to demonstrate compliance with the GDPR principles. And SSI could also help there, because you could keep track of the consents and show compliance. And you could also, what you also saw is that build consortiums between different organizations, and then it is also pretty clear who is the data controller. And in this consortium, which are probably most of the time permissioned or private chains, can have a certain trust framework, legal agreements between the different validator nodes or entities running the blockchain. Yeah. This is not specifically SSI related, I have to admit. So what is uPort? uPort is, how much time do we have?
Officially 10 more minutes.
Okay, cool. Just, I think that, have you heard about uPort? Because I think I make it short. uPort is a self-sovereign identity solution based on the Ethereum blockchain. We are live today. We provide an open source platform which could be used by developers. We have smart contracts, smartphone apps for Android and iOS. We have libraries which make it really easy to integrate your service provider with SSI. Also makes it easy to become an issuer and create these credentials. Also have SDKs and tools on top of that. It's live in the production today. We are focusing on really simple and rapid integration. No additional infrastructure is required. You don't have to run your full node. Something based on standards. We are anchoring our identities on the blockchain rather than storing it. We can create millions of identities a day, even without sharding and Casper and Serenity. And we support all types of EVM compliant blockchains, also permissioned and private blockchains. And we don't store API on the blockchain. We always ask the user for explicit consent, implementing data minimization best practices, what passwordless authentication or single sign-on with service providers.
What is the consent for?
The consent is for? Okay.
Why do you ask for consent if you do not store your...
Consent is for because we don't store it, but the data controller processes it, right? So the user is asked to share the data, and the user will then present the purpose, and also who is the requester or the verifier, and what type of information is he requesting. It's actually, do you don't think it's needed?
No, I'm just asking myself what will happen when a user is withdrawing his consent or her consent.
Then the data won't get shared.
But still somewhere.
No, the data is actually only on the smartphone of the user. We are implementing a recovery strategy based on seed phrase, and I showed you earlier the uPort stack, and you could use either as an integrated solution or individual components. Also build your own governance or trust framework on top of that.
I think that's a cool idea. So the data is then really just on my phone, you said?
Yeah, it's there are concepts like the Edge wallet, which is normally on your mobile phone, or you have a cloud agent or a cloud wallet, where every data is encrypted using the key that is stored on the mobile phone. And then, so the user is still under control of the key, so it's not possible to decrypt the data in the cloud because it's encrypted.
I can drop my phone as well. Because,
yeah, I mean, there are different approaches for key recovery. One of them, which is very promising, is sharding signature. I haven't seen any really good implementations out there, but we're working on it. Yes, it's a uPort stack. We also have a developer documentation online, which is quite helpful. Just give you a quick overview of some projects that we did. Crypto Valley in Zug, we introduced a city ID for the city of Zug. They applied for a city ID, got the uPort ID verified, and then they will be able actually to use e-governmental services in Zug. One of them was e-voting, but only low assurance use cases, not like governmental. Another one is a project that we did with SBB. If you have 5 minutes, I can show a demo. It's the last slide, actually. Sound.
Currently involves multiple parties making entries and railway inspectors recording inspection processes using paper. These complexities and inefficiencies created an ideal opportunity for a blockchain pilot. Using uPort, a small dedicated team co-designed a solution that provided real business value. Here's how the solution works. Welcome to the SBB pilot homepage. Railway worker Hans Muller scans a unique QR code of the city of Bern using his mobile phone and is issued an identity certificate. Hans will already have the uPort app pre-installed and an ID created. One scan, Hans approves the transaction and then accepts the certificate. This digitally certifies his credentials on the Ethereum blockchain. Similarly, to attain his ID certificate, the railway QR code is then scanned. Hans approves the transaction, accepting the certificate. certificate issued to as uPort ID. In this case, the certification proves hunters qualified for well-link. For both check-in and check-out to a site, you will need to approve the credential request. Upon successful check-in, a screen shows that he has been verified. Upon successful check-out, a screen also detailing his time on site is shown. This pilot could be a part of the broader Swiss ID and digital identity discussion in Switzerland and serve as a model.
Yeah.
We have a question from the stream. The question is from Nico B. Do we get that right, that the SSI solutions are based on a trust authority, the credential issuer? You have to trust them. How can I be sure that if you don't know the issuer, the identity of a user is trustful?
Yeah, so actually it depends on the policy. So the policy has to be implemented by the verifier. So the verifier, of course, has to trust the specific issuer. The verifier can also decide to say, okay, the user self-attested something, but it's up to the verifier to decide. That's true. Yeah, but I won't say that SSI is about trusted authorities. It depends on the use case. So, for instance, in the governmental area, you would definitely rely on a trusted governmental issuer, or like a bank or insurance company, a company that has a reputation and stuff. But other use cases, like, okay, if I want to log in or sign up with Spotify or Airbnb or something, then all the data is self-attested. I think that they should be fine with that approach. So it really depends on the use case. Thank you.
So any questions or otherwise lunch is here? Yeah. There's one more question from the stream. Are there attempts to find a solution without trust of authorities like ZKP?
CKP?
ZKP?
Zero knowledge proofs?
Yeah, I guess so.
I'm not sure if this is related, but so there are different approaches to trust. There's also one approach which is about reputation-based trust. So there's also some work ongoing in this area. So they also sometimes call it the web of trust. We saw similar approaches in the past, but I must admit I'm not an expert in the reputation-based system, but there are different approaches. I mean, the easiest approach is to have a trust list, a list or many trust lists of trusted authorities, or trusted universities, banks, etc. Another approach is to use reputation.
So